Okay, hello Year 11. This is homework number 7. I had to re-record it because I kind of got to a few questions in and then the file kind of corrupted. But that's the way it goes sometimes. But thank you for joining me on this homework, which is looking at transformations, algebraic fractions, and vectors. Now I'm going to read the front cover here so you can kind of just make sure that we know definitely what's going on. And it says, because you've already had a homework on circle theorems and we've only just finished this topic, circle theorems, kind of last Friday, I could have given you another homework on circle theorems because that's what we've been doing, but I thought you've already done this, so I thought it'd be useful to recap content from earlier this year, which is the transformations. It's going to be section A, algebraic fractions section B, and vectors section C. So these are all topics we did right at the start of the year, which we didn't really do homeworks on like this, in this kind of style. And so I think it'd be really useful to recap them again in this homework. Now, I've put on the second paragraph, it's really important you try and do the questions first. Now, these videos, I think, are transformative in the way they can help students, but you've still got to do the questions first yourself, try them, get stuck, try and think your way around the question before you use the videos for help. If you just rely on them all of the time, you won't develop that sort of resilience and thinking you need in the exam. So it's really important you try the questions first. If you get stuck, of course, then use them to help you and to mark your work once you've done a question. But you've got to try the questions first. Now guys, section A, which is going to be this video, is looking at transformations, which is the first topic we covered this year. And just reminding us, there's 4 different transformations. Translations, which is the movement across and up and down. Reflections, like in the mirror stuff. Enlargements, getting bigger or smaller. And rotations, spinning round. Also, invariant points is a point or coordinate that does not change under a transformation, and that's going to be useful in one of the questions at least. But without further ado, let's get into question 1 in section A, which is transformations. The question says, shape A and B are shown on the grid. Describe the single transformation that maps A onto B. Now, straight away, I know that this must be an enlargement because my shape from A to B has got smaller, and enlargement means getting bigger or smaller. So for 1 mark, straight away, I'm going to write down that this is definitely some sort of enlargement. Okay, and that's going to get me straight away 1 mark. Now I'm going, be careful, from A to B. So from the bigger one to the smaller one. I've got a smaller, which is important to bear in mind. If I take a corresponding side, so this bottom side here, which is 4 squares across, and I choose the same side on shape B, which would be this one, they're the matching sides. That side is 2 squares across. You can see here from 4 to 2, I've halved. Let's just double check it makes sense on another side. This tall side here is going up by 6 squares, and on this one, it is going up by 3 squares. Now these are the matching sides, it's just that B has been kind of flipped around. So from a 6 to this one, which is 3, again, you've halved it, which must mean that your scale factor, which means you're getting bigger or smaller by some number, is going to be a half. Now, it's not just a half, because you can see that A and B are kind of being rotated around, that's the negative scale factor variation, where your number must be minus. So the scale factor is minus a half. Okay. Now, we're missing one more thing. We're missing the centre of enlargement. So that's 2 marks in the bag there. I've got to go and get the centre of enlargement. Now to get this, and the centre of enlargement isn't, the centre kind of makes it sound like it's going to be the point 0, 0. That's not what it means. It means I've got to go and match the corresponding point. So this one up here is the same as this one down here, just being kind of moved around. These points here, they're going to be matching up, and use a ruler and a line going through them. Similarly, if I choose other matching points, so for example, this point here and this point, they're the same point on the shape, just being flipped around on B. If I draw a line connecting these 2 points, okay, there we go. We can see that they cross over at this specific point, which is the point 7, 4. Now, just to make sure that's definitely the correct point, I'm going to just make sure that this point over here and this point, which are the same points on the shapes, just flips over, they should hopefully go through the same point, which they do. So this point here is the centre of enlargement. So this specific coordinate is the centre of enlargement, which is the coordinate 7 and then 4. So the centre of enlargement is the coordinate 7 and then 4. And that is the final mark. So you can see, even writing the exam, you completely crumbled. You get a mark just for saying enlargement and by saying a scale factor of -1/2. And the final one by saying the centre of enlargement is 7, 4, which is this point down here. And that's the 3 marks in the bag. Okay, question number 2. We've got here, it says the following. Triangle ABC, this one over here, is drawn on the grid. ABC, this triangle is transformed to A-B-C-, which just means the new triangle, by a reflection in the line x = 1. Let's just deal with this one first of all. Now, the line x = 1, well, the x-axis is here, the point 1 is here. It's going to be a line going through that point there. So this here is your reflection line, x is equal to 1. To reflect a shape is nice and easy. I choose a point like C, I count to my mirror line, which is 1, 2, and then count back outwards again, 1, 2. It's going to be going to the point 3, 1. So this is the first point. Now this was the point C. It's been moved to C', which is what this means. It just means that's the new point, C'. I then go and choose point B. I count to my mirror line, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 to the point 6, 1. That goes in there, and that's going to be the point B'. The final point is point A. I count to the mirror line, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 again. We'll be going up here, and this is the point A'. So this is my new shape, A', B', C', and that's really messy. Up here. There we go. There we go. And there we go. Line 2 then says, so I've already got 1 mark already. That's going to be 1 mark in the bag. Line 2 then says A', B', C', which is this shape here, is transformed to a new shape by a rotation, so spinning around 90 degrees anti-clockwise. So you're going this way. 90 degrees is a quarter turn, about the point 1 minus 4. So identify the point of rotation, 1 minus 4, which is going to be going 1 minus 4 over here. You're then going to get your tracing paper, which I'm just going to, I can't show you this very clearly on the screen, but just pretend, and you can do this with your tracing paper. We've got tracing paper here. We're going to just sketch over everything. You would then draw over your shape here on the tracing paper. You'd put your pen or pencil onto the center of rotation, which is here, and you would spin the paper around, and if you did all of this, you would see that the new shape goes to, I've got to look at the mark scheme because I can't actually do this on my screen, but it would go to this, so 2 across there, 3 down there, and then up here. Okay, so if you performed this rotation, that's really messy, isn't it? Sorry guys, let's redo that. There we go. If I perform this rotation, this line here, I would go from this shape to this shape. The question says which one of the points on ABC on the original shape here is invariant, i.e. it's not moved. Well, you can clearly see that point B is the one that has not moved. It's the same on the starter shape and on this new green shape. So the point that is invariant, and I've shown it through my working, is point B. The question says you must show the results of each transformation on the grid. I've done that. That's the first one. That's the second one. And that, guys, is 4 marks. The sort of thing, guys, that if you practice it, it becomes really, really easy. There's nothing complicated here. It's just practicing the questions and becoming familiar with the questions. Okay, question number 3. This is where it corrupted on the previous video, so I'm glad it hasn't this time. This question, let's zoom in a little bit. This question says the following. Triangle ABC and DEF, so ABC and DEF are shown on the grid. Describe a single transformation that shows the triangles are congruent. Don't let that confuse you. Congruent simply means identical. And you can see on the diagram, let's make a note of this, right, that means identical. You can clearly see that these triangles are already identical. They're going 3 across on the base and they're meeting at the same point up here. These shapes are already identical. Now, which one of your 4 transformations is it going to be? Is it going to be a reflection? No. Is it going to be a rotation? No. Enlargement? No. It's got to be a translation. It's got to be a translation, because a translation just moves a shape up and down and sideways. Now, to get this correct, you've got to be a bit careful here. You're going to choose the matching points. So we're going to go and choose this point here and this point over here. And just remember, okay, when we move using a vector, the top number is horizontal movement, where across to the right is positive, left is negative, and then up and down, up is positive and down is negative. So to get from C to F, we're going across by 1. 1. I'm going to actually count it on my thing. So 1, 2, 3, 4, 5, 6. 6 across, and then up by 1, 2, 3, 4. Notice here, I'm going to the right, that's positive. I then go up, that's positive. You could have also gone up by 4, across by 6. It makes no difference, because you're just going to be writing it, making sure the top number is the horizontal part, 6 across, and the bottom number is the vertical part, which is up by 4. Now, just to make doubly sure this is correct, it should be the case if I choose other corresponding points, like this point and this point. You should be going 6 across, 1, 2, 3, 4, 5, 6, up by 4, 1, 2, 3, 4. It makes sense. Okay, so there we go. That's it. That is just a simple 2 marks in the bag. 1 mark for the statement translation, 1 mark for the vector, 6, 4. Done. Okay, and that is it for section A of the homework on transformations. Hopefully that video was useful. If you could give it a like, that would be really useful. I really appreciate it. It gives me a bit of inspiration, and I just really appreciate it. But hopefully it was useful and you've marked your work, and that's it. We'll go on to section B in the next video.